Alright, this is lesson 56 for 7th grade, and today we're going to talk about plotting functions. It's a lot, basically what you can think of when you see the words plotting functions is that we're going to be graphing, okay? We're going to take graphs and or points, we're going to plot them onto a XY plane or the coordinate system, and we're going to get a graph out of it, okay? So function is another funky word for graph. So let's remember, because we've talked about functions a little bit, that a function is a mathematical rule defining the relationship between two sets of numbers. Okay? The numbers may be counts, or they might be measures. In this lesson we will write function rules as equations, plot functions on a coordinate grid, and determine function rules from plotted points. Alright, so we'll kind of take a look at some examples like we usually do, and we'll see what they're talking about here. Okay, so this first one says, Jamal is ordering chairs for the furniture store. The function table shows the number of chairs he orders for each table. So remember, a function is some sort of equation where when we have an input, it will give us an output number. So looks like, for every table we have, we're going to have 4 chairs. So let's look at it as we go down. So if we have 2 tables, that means we're going to have 8 chairs. 3 tables, 12 chairs. 4 tables, 16 chairs. So it looks like we're going by 4s here. Or basically, every table is going to have 4 chairs. Okay. So there is a way that we can write this rule in words. Oh, I see. Write it in words. Okay. So we already said that. We said that each table gets 4 chairs. Alright, so for every table there will be 4 chairs. Okay? That says now we want to complete the function table to find out how many chairs he'll order if he has 5 tables. Okay, so it looks like since we're going to have 4 chairs for each table, if we have 5, we just take each input and multiply it by 4. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. Okay, so 5 times 4 would be 20. So it'll be 20 chairs. If there are 5 tables. Now it says it wants us to write the rule of the function table as an equation. Use the letter Y to represent the number of chairs and X to represent the number of tables. Alright, so I'm going to put C down here. So we're going to have Y equals X, or something of that fashion, okay? We have to put the output is all dependent upon what the input's going to be. So I'm going to write C up here. We're going to have Y equals, and it looks like whatever Y is, it's 4 times whatever X is, okay? So to get Y, we have to multiply this by 4. So I have to multiply all the X's by 4 in order to get those outputs. So once again, the output depends on what the input is. So that's why the 4 goes with the input. Because if we check this out now, if X equals 1 table, 4 times 1 gives us 4 chairs. 4 times 2, if we have 2 tables, 4 times 2 gives us 8 chairs. So that would be our equation that we would write for C. Alright? Y equals 4 times X. Or the number of chairs equals 4 times the number of tables that we have. Alright? We can use the number pairs in a function table as coordinates of points on a coordinate plane. Then we can plot the points. For the function in example 1, we can plot these points. Alright? So our X table, so let's see, we had X was tables. Yep. Y's were chairs. And if we had one table, we had 4 chairs. 2 tables, we had 8 chairs. 3, we had 12, and it kept going. Alright, so we can think of these as ordered pairs. Or points that we can plot on a graph. Okay? If there is one table, there are 4 chairs. Okay? That's how it's working. So they took all of these and plotted them on a graph. 2 tables, we'd have 8 chairs. 3 tables, we would have 12 chairs. Okay? So it keeps going up like in that fashion. And it would form a line if we connected, or an array, or a line segment if we connected all of those. Okay? And we would see a linear pattern. So it's a set of unconnected points for this graph that are aligned. And like I said, we could connect these points, but in this, we could in a normal graph. This one's a little different though. These points aren't connected because there's only whole tables that we consider. So there wouldn't be a point right there because this would mean like 1.5 tables. Okay, so there wouldn't be a point there if I were to draw and connect these because we don't consider fractions of a table, we're only considering whole tables. So that's the reason why this graph isn't connected, alright? So it's tempting, and even when I said that you could connect them, this one we can't. But in most graphs, we will connect our points, alright? They are aligned still though because we had a constant that we're multiplying by, which was 4. Alright. Oops. Let's take a look at this. Check my time quick. The function y equals 2 times x doubles every number that is put into it. If we input 5, the output is 10. If we input 10, the output is 20. Below is a function table that shows some input-output pairs. I put it on the side here. Graph all the pairs of numbers for this function. Okay? So basically, we're doubling x, or our output is double what x is inputting. Okay? So we have our xy's, and they're not going to use any negatives, it doesn't look like. We could. And this graph could go negative. It doesn't ask us to do that. I can show you real quick once we graph the positive ones. Anyway, this would be positive 5. 1, 2, 3, 4, 5. Okay. So it goes up to 8. Alright, so first point is 0, 0. Over 0, up 0, right there. Second point, over 1, up 2. Over 2, up 4. So about right there. Over 3, up 6. About right there. And over 4, up 8. About right there. So my graph won't be perfect, but we get a relationship that looks like that. Okay? And I got all those points from right here. Over 0, up 0. Over 1, up 2. Over 2, up 4. Over 3, up 6. Over 4, up 8. Okay? We could put in negatives if we wanted to. We won't get into it yet. It doesn't look like. But if I put in negative 1, that would be what is y when x is negative 1. 2 times negative 1 is negative 2. And if we were to plot that point, that would be negative 1 down 2, about right there. So we could get negatives and that graph would go down as well. Okay? Our other one didn't, remember, because we were talking about tables. Alright, you can't have a negative table, just like we couldn't have 1 1/2 of a table. This graph is connected because I could put in, for instance, I could say, what if x was 1/2? Well, 1/2 times 2 is 1. Okay, so we would go over 1/2, which would be in here, up 1. So about right there, okay, and it would still be on our line. So that's why we connect the dots in this one. And this is our intro to plotting functions, so we'll definitely be talking about this quite a bit. This helps us get into algebra a little bit. I think I have one more example for us. Okay. The illustration shows the graph of a function. Refer to the graph to answer A and B. Alright. Let's see. Write the coordinates of 3 points on the line that represent the function. Okay. We're going to name off 3 coordinates. So, points. Alright. So we want to name points that we know that are for sure on this line. Looks like it goes through the origin. Right there. That's our 0, 0. Okay, so there's 1 point. Let's see. Looks like the line definitely goes here. Alright. Right there. Over 2, up 1. Okay? And I know that because it crosses through where it goes over 2, up 1. So I'm looking for where it crosses between the two lines, basically, where they intersect. Okay? So over 2, up 1. Okay? That would be a point there. And one other point that we can see, we could do a negative 1. Looks like it goes negative 2, down 1. We could go over 4, up 2. These are all on there. Alright. How about, just for fun, we do negative 2, negative 1. That's also on there. So there's 3 points. Now it says, using x and y, write the rule of the function as an equation. Do all the xy pairs from part A satisfy the equation? We'll check. Alright, so we want to use x and y, we want to write the rule for the function. So, it looks like, if I write these out here, all of our x's are 0, 2, negative 2. Our y's are 0, 1, negative 1. A couple of the other ones we didn't put. Over 4, up 2. Okay, there's another one. Alright. So what does it look like is happening from x to y? Whatever we input, or we put in for x, y appears to be half of whatever the x value is. Half of 2 is 1. Half of negative 2 is negative 1. Half of 4 is 2. So our rule is that y is going to be half of whatever our input is. Half of x. Okay? And that should make sense. If I put 0 in for x, 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 of negative 2 is negative 1. Half of 4 is 2. Alright? So that's where we're getting that from. Alright, I think that's all I've got. So, like I said, we will continue with more of this sorry, tripping up on my words. We will definitely continue with this because this is just the beginning of our plotting functions. Very important topic.